This video will cover questions regarding the topic of related rate, the shadow. Question 1. The ground. The street light is here, which is 18 feet above the ground. A man 6 feet tall walks away from the street light. The shadow is here. Let x be the distance between the man and the street light. Let s be the length of the shadow. A man 6 feet tall walks at a rate of 4 feet per second away from the street light. That means dx dt equals 4 feet per second. When he is 10 feet from the light, that means x equals 10 feet. At what rate is the length of his shadow changing? That means we are looking for ds dt. If we redraw this situation a little more simply, these two triangles are similar because they are both right angles, and these angles is the same. Then we can set up 18 over x plus s equals 6 over s. Then cross multiply. 6 times x plus s equals 18s. Then 6 times 1, 6 times 3. Then x plus s equals 3s. That means x equals 2s. Then differentiate implicitly with respect to t. d dt of x equals d dt of 2s. Then dx dt equals 2 times ds dt. Now plug in the information. Dx dt is 4 equals 2 times ds dt. That means ds dt equals 2 feet per second. The length of his shadow is changing at a rate of 2 feet per second. At what rate is the tip of his shadow moving? That means we are looking for dx plus s dt. Usually students can easily understand the question of finding the change in the length of the shadow. But if the question is the situation where the tip of the shadow moves, it's harder to know what to look for. If you assume that the man is directly under the street light, the shadow will look like this. Assuming he walks away from the light a little, then here is the tip of the shadow. If he is here, then this is the shadow. The tip of the shadow is here. So now, don't think about the length of the shadow. Let's just think about the situation where the tip of the shadow moves from here to here to here. So we need to find the rate of the change of the distance from just under the street light to the end of the shadow. Then go back to original. dx plus s over dt. That means dx dt plus ds dt. Then dx dt equals 4 plus ds dt equals 2. The final answer is 6 feet per second. And in this question, it doesn't matter how far the man is from the street light, because if he walks at a constant speed, the length of the shadow or the rate at which the tip of the shadow changes is always the same. Question 2. The ground. The spotlight is here. The wall is 15 meters away from the spotlight. A man 2 meters tall walks from the spotlight towards the wall. The distance between the spotlight and the man, let's say x. Let y be the height of the shadow. Because of this, dx dt equals 1.2 meters per second. Because of this, we are looking for dy dt. When he is 6 meters from the spotlight, that means x equals 6 meters. If we redraw this situation a little more simply, then these two triangles are similar because they are both right-angled triangle, and this angle is the same. We can set up 2 over x equals y over 15, then cross multiply xy equals 30. Differentiate implicitly with respect to t. d dt of xy equals d dt of 30. Using the product rule, dx dt times y plus x times dy dt equals 0. Now plug in all the information. Dx dt equals 1.2 times y equals, when x equals 6, plug in here, 6 times y equals 30, that means y equals 5 plus x equals 6 times dy dt. 1.2 times 5 equals 6 plus 6 times dy dt equals 0. Then 6 dy dt equals minus 6. dy dt equals minus 1 meter per second. That means the shadow is decreasing at a rate of 1 meter per second. This is the third and the last question. The building and the ground is here, 40 meters. The sun, this is the shadow, let's say S, let's say theta. The sun makes the angle of elevation with the ground. The angle between the sun and the ground is increasing at a rate of 0.3 radian per hour. That means d theta dt equals 0.3 radian per hour. The shadow of the building on the ground is 30 meters long. That means S equals 30 meters. At what rate is the shadow length decreasing? That means we are looking for ds dt. In this diagram, we know the respective angle, the opposite side, and adjacent side, so we can choose a tangent theta. 40 over s. Differentiate implicitly with respect to t. d dt of tangent theta equals d dt of 40 over s. Then secant squared theta times d theta dt equals d dt of 40 over s equals d dt of 40 times s to the power of minus 1. That means minus 40 s to the power of minus 2 times ds dt. Then we can rewrite as minus 40 over s squared times ds dt. Then back to the original, minus 40 over s times s squared times ds dt. In this situation, 40, s equals 30, then hypotenuse is square root of 40 squared plus 30 squared. That means the square root of 2500, which is 50. That is theta. Then cosine theta equals 30 over 50, which is 3 over 5. Then secant theta equals upside down, which is 5 over 3. Then back to the original, 5 over 3 squared times d theta dt equals 0.3 equals minus 40 over s equals 30. Squared means 900 times ds dt. Then 25 over 9 times 3 over 10 equals minus 0 is cancelled 4 over 90 times ds dt. Then times 90 on each side, that means cancelled. So 75 equals minus 4 ds dt. Then ds dt equals minus 75 over 4 meters per hour. That means the shadow length is decreasing at a rate of 75 over 4 meters per hour. I hope this video has been helpful. If you have any questions, write them in a comment. Thank you for watching. Please like and subscribe for more.